Okay, so let's finish up where we left off here. So we're trying to prove or see if these two lines intersect. So when things intersect, that means their x's, their y's, their z's have to match up. So that means that this guy over here, this x value has to match this x value. So that means that we have 6 plus t has to equal 5a plus 7. And then also we have the y's. Negative 5 minus 2t has to equal 2a plus 5. So you see why I had to use two different letters for the different lines, because I can't have the same letter twice on both sides. Okay, and then I have 1 plus 3t has to equal 3a minus 8. So think of it conceptually, like they have to equal each other, and then you'll see what to do. All right, so when I'm looking at these, there's only two variables, so all I need is two equations. So when I look at these, like which two do I like? I think I definitely like this guy because he has that single 6 plus t over there, that t. And then why don't we just use this one also? All right, so I'm going to multiply the top one by positive 2 so that the t's will cancel out. Let's see what happens. So I get 12 plus 2t, we're solving a system of equations, equals 10a plus 14. And then I have negative 5 minus 2t equals 2a plus 5. So I'm going to add these two lines together just like you would in Algebra 1. So this cancels. So I get 7. I got 12a plus 19. Let's take away 19 from both sides. So I have negative 12 equals 12a. And so a must be negative 1. So once I know a is negative 1, I'm going to use that in either of the two equations that I just used. So I don't know, I guess I'll just put it in this one. So 6 plus t equals, if a is negative 1, I get negative 5 plus 7. So I have basically t, let's see, on the right side I'm going to get a 2. So 2 minus 6 is negative 4. All right, so I need to go through and plug these values into my lines. Plug the t value into line 1, plug the a value into line 2, and let's see if they meet up. If they both produce the same point, then I know that they meet up. If they don't, then they're skew. Because I could already tell, frankly, that they were parallel. Remember, if they're parallel, the direction right here would be a scalar multiple of the direction here, and I can already tell that they're not. So I knew that they weren't parallel to begin with. All right, so let's try the plug-in. So on line 1, I'm going to be using my t value. So t is negative 4 in here would produce 2. Negative 5 plus 8 is 3. And on the bottom, 1 plus negative 12, that would be negative 11. So I check and make sure. Over here, when I'm using a, on this guy, 5a plus 7, so 5 times negative 1 plus 7 produces 2. Put a negative 1 in the y value, produces 3. And so that's supposed to match. I literally just proved that the t and the a that I did, those were the first two equations that I used. So since I used the top two equations to make the t value and the a value, those should always match. It's the third one that's the test to see if it actually meets up. So in this case, let's see, put a negative 1 into 3a minus 8. I would get negative 3 minus 8, so negative 11. And so they meet up. And this is the point of intersection. All right, so do you remember what skew lines are? We talked about it in class. So these are, I guess they're lines on parallel planes. They never intersect or anything like that. So I guess they could be parallel lines. I guess parallel lines are also skew in a way, so probably the same thing. All right, so let's take a look at this next one here. So what are two situations where lines would not intersect? Well, I think I just mentioned it, parallel, or they would be skew. Okay. Okay, so prove that two lines do not intersect. These two lines do not intersect. So first of all, I go ahead and check for like the direction. Are they parallel? Well, this one is kind of different. This line right here, its direction vector, the x has just a 2. So its direction for x is 0. The direction for the y is a 1, and the direction for the 2, or the z, is a 2. And the direction vector down here is going to be 1 in front of the u, and negative 3, and negative 2. They're both in parametric form. So these are not multiples of each other. So they're not parallel. So not parallel. All right, so let's see. I mean, they're not going to intersect, but I want you to see like why. So what I would do is I would set the x's equal to each other. So I got 2 equals -1 plus mu. I have the y's, -1 plus lambda equals 1 minus 3 mu. And the last one, 2 lambda equals 1 minus 2 mu. All right, so I definitely want to use this equation because duh, it only has mu in it, so I can solve for mu. So how about I use that one and this one right here. So let's see, I don't really have to do a system. I mean, this is my system, but like I can just solve the first one. I can say that mu has to equal 3. And knowing that mu equals 3, I'm just going to go ahead and plug it into here and go ahead and say that 2 lambda equals 1 minus 2 times 3 is 6. So I get lambda equals -5/2, -2.5. All right. Okay, so now what we're going to do, that's not right. Hang on a second. Oh, well, no, that's fine. It's fine, actually. I guess in my notes in my own, I used the second equation, which came out a little bit easier. But we'll just go with what we got here. All right, so let's test out line 1. So line 1, we're going to be using lambda. So lambda has to equal -2.5. And in line 2, line 1, line 2, we're going to be using mu equal to 3. All right, so in line 1, lambda is -2.5. Well, the point that I would get, this 2 doesn't change, so that's still 2. -2.5 right here means I would have -3.5. And -2.5 right here means I would have -5. All right, and then for mu equals 3, so mu equals 3 right here would mean I would get 2. Notice these two things match because this was one of the equations I used to actually make it true. All right, and then on the next one, mu equals 3 right here. So 1 minus 9 is -8. Mismatch. All right, and the last one, if mu equals 3, I get 1 minus 6, which is -5. So again, notice the matching right here, and then in the one that I didn't use, it doesn't match. So did you notice that, like, right here, this does not match that, and so that's where I know that these two things are skew. These lines are skew, all right? Okay, that third one that I never touched earlier is the part that proves that they're skew. All right, so let's take a look here. So now we're doing planes, so your flat surface. So remember when we were doing cross products, I made a big deal about like the normal vector. And when you do the cross product, it produces a third vector that's perpendicular to both the original two. So that thing right there, see this normal vector right here, that's what you need to tell the direction of a plane. Many planes can go through a line, so you cannot use a line to tell the direction of a plane. But if you know a vector, or a line basically, that is perpendicular to your plane, then you know the direction of a plane because it has to butt up against it at a 90-degree angle. Okay, so I just wanted to mention that here. So remember, the direction of a plane is its normal vector. So remember that the normal vector is the direction of the plane. That's the only thing we can say, because many different lines, many different vectors lie on a plane. Only one vector is perpendicular to a plane. All right, so here's our equation for planes in space. All right, we have a couple of different formats. Actually, we'll just do we won't do the third one right here, but we'll cross this one off. All right, so the first format is this. A, x minus x1 plus b, y minus y1 plus c, z minus z1, oops, equals 0. Now, let me mention up above, I wrote it up here, but your plane has this point, and your direction of your normal vector, your direction of your plane, the only direction that you know about your plane is this guy right here. So remember, ABC is not the direction of the plane anymore, it's the direction of something perpendicular to it, but that's all we know. All right, so you put them in your formula, and there you go. So now, usually what you're going to do, you're not going to leave it like this right here. You're going to multiply it out. So what's going to happen is you're going to get a times x And then you're going to have a times x1 when you distribute. Well, a times x1 is going to be a number. And then b times y1 over here is going to be another number. And then c times z1 is going to be another number. So you're going to collect all those numbers together, and you're basically going to put them to the other side. So you have plus by. So the simplified form of the first equation is this, plus cz equals d. So the d value is on the other side there, and it's basically just a collection of the constants, which you'll see in a second. All right. So let's do this next one right here. So finding the equation of a plane is kind of a big process because we need that normal vector. So you see this picture over here has the points in it and everything that I want. All right, so I want the equation of that gray plane surface. So it's going to be quite a big deal. I'm going to have to find this vector. I need to find this vector. And then we're going to do the cross product of those two things because I have to find a normal vector for those things. All right, so let's do it over here. The vector between 2, 1, 1 and negative 2, 1, 4. So I'm going to subtract them. So negative 2 minus 2 is negative 4. 1 minus 1 in the middle is 0. And 4 minus 1 is 3. So there is that vector. Now I'm going to do a vector from 2, 1, 1 to 0, 4, 1. That's vector u, I guess, in this problem right here. All right, so 2, 1, 1 to 0, 4, 1. 0 minus 2 is negative 2. 4 minus 1 is 3. And 1 minus 1 is 0. Okay, so it doesn't really matter. You can do either way. So we're just going to go ahead and do the cross product. I'll just keep, darn it, this thing better not start moving again. I'm going to be really angry. All right, so I, J, K, all right, so I, J, and K. And let's see. So I have my negative 4, 0. I'm going to kill this thing. 3. All right. And underneath I have my negative 2, 3, 0. All right. Okay. So cross product. So if I want my cross product, then I cross off the I column. So remember, I'm doing the determinant of this thing. I'm going to pause this, and I'll be back in a second. All right, so we'll finish this example, and then I'll stop. So I'm doing the, okay, I still have the pointer on, sorry. I'm doing the determinant here. All right, so the only way I know how to get it to stop moving around like that is to go ahead and like close this thing out and then like open it back up. So that's what I did. All right, so I cross off the I column. So if I'm doing the determinant of those other 4 numbers, 0, 3, 3, 0, I get 0 minus 9, so negative 9. Let's see, cross off the J column. I would get 0 minus negative 6, so 6. All right, cross off the K column, I would get negative 12 minus nothing. Oops, I forgot to put my 6 negative. And so then the K would be negative 12 minus nothing, so negative 12. Okay, all right, so at this point, we're going to take that. So we're going to have, that's our ABC. So I'm going to put negative 9. And then I have x minus something. Then I have negative 6. I have y minus something. And then I have negative 12. And then I have z minus something. And then equaling 0. All right, that's our first format. Okay, so let's put in our point. We can use any old point we want. So how about 2, 1, 1? So let's put a 2 in here, a 1 in here, and a 1 in there. And if it's ever negative, then it would change it to a plus. Like if I had used this point right here, it would have turned into x plus 2. All right, so let's work this out. I get negative 9x plus 18 minus 6y plus 6. And let's see, minus 12z plus 12 equals 0. So you should work this out. You can't just leave it like it was earlier. All right, so this is what I mean by you have all these constants. So notice that you have this 18, this 6, this 12, and they can be positives and negatives just depending on the problem. So let's collect them all onto the right side. So I have negative 9x minus 6y, let's see, minus 12z equals, let's see, 18, 6, and 12. So that's 36 that adds up to. And it's going to turn negative on the other side, so negative 36. So there's your equation of your plane. Now, hopefully you noticed you could do some things to fix this up a little bit, like everything divides by 3. So you could divide everything by 3 to make it a little simpler. You could also make everything a positive, okay? But I want to show you one cool fact. You know, all this work that we just did right here, you can simplify that a little bit better, or make it easier. So watch this. All right, so this number over here, this 36 that we all got, notice that it is the dot product of our normal vector and this point. You see what we were doing is we were just multiplying -9 times -2. We were multiplying that, right? We were multiplying this. So all I was doing was multiplying this and adding them together. And let me show you what you're going to do. So if you do the dot product, -9 times 2 is -18. -6 times 1 is -6, and -12 times 1 is -12, and you're adding those together, you get -36, and look, it's right there. So a little quick thing that you can do if you want the equation of a plane, once you find your normal vector, you stick it in front of your x, your y, and your z, and then you dot product the normal vector with any point, and you put it on the other side. See, if we had used this point, if we dot it with -9, -6, -12, I would get 0 plus -24 plus -12. I would get -36 again. It doesn't matter which point you use. So let's remember that, and we'll do that in class next time. All right, so let's see. Let me pause for a second and see how much of the homework you can do, and just a couple problems. All right, so there's your homework list right there. So let me tell you, you know how to do through number 33 right now. If you don't have enough time to do all those, 7 problems in the front right there, 1, 2, 3, 4, 5, 6, 7, at least do like maybe 4 or 5 of them, something like that. So that way we don't have to spend as much time on it in class next time. All right, so get a few of those problems done, 7, 10, 16, 21, 22, 23, 33. But we're going to do the rest of the notes in class, and you'll be responsible for the rest of those problems later because you do not know how to do these right here. Don't do those. All right, I'll see you in class. Bye.